previous lecture was relatively long, and I sort of just want to make a brief overview of the Amz5x12 matrix in the specialized chemical configuration, in which we have 12 rows, 12 columns, and 10 rows, and 120 elements. And the last two is yet to be fully realized. On helium and unbiennium, this is 119, this is 120. And we note again that in other presentations we have 1, 2, hydrogen, helium, lithium, beryllium, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12. And in this case we have 12, 13 below, aluminum, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium, 20 calcium, 21 scandium, 22 titanium, 23 vanadium, and 24 chromium. But in our presentation we have the aluminum on this side, so we have 1, 2, 3 to 12, and then we come across to make it 13, 14, 15, 16, so on. Still consecutive order, but I've learned not to, it's better to do it this way. Because when you come across, you're more liable to make mistakes. Because it's hard to make a jump in space there. You just come down here for 13, or you have to come way across here for 13. I know, and so that's the difference in our presentation. And we note, so we have the whole 120 elements, yeah, and specialized elements in my notebook would be uranium, atomic number 238, and plutonium, atomic number 231. Well, erbium I know 168 due to my PE licensing examination preparation. Score. And samarium likewise. Where's samarium? Samarium is 62. SM 62. 60 here. 62 samarium. And this would be about 158, I believe. 157 atomic weight. First 120 is just approximately doubling the atomic number to get the atomic weight. Well, sodium we know 23 is a more accurate number. If we double 11, we get 22 plus 1. Chlorine, I think, is also like 35. This is from doing a lot of molarity calculation with concentration equal molarity times molecular weight. Chlorine, so I think this is 35. Some of them I sort of can remember from high school days. You know, sodium is 23. Oxygen, if it does, we get 16, but it's actually 15.999. Yeah. So we have uranium and plutonium, and we have like oxygen, we do remember those. The first 120 is approximately doubling the atomic number to get atomic weight. And those are the special one that I mentioned is due to some special significant number that I try to maintain the atomic weight for. Plutonium, uranium, gold, 79 atomic number 197. This is another one. I'll tell you exactly, or you can remember this. You just drop a 1 in front of the atomic weight. And likewise, erbium, you drop a 1, but in front, but with the goal to drop it. So you get 197. 1 here. You drop it on the right hand side, and you drop this one on the left hand side. So it's easy to remember the atomic, and you should remember the atomic weight for gold. You know? Nobody can fool you if you go there to buy gold. How much atom of gold you should have, how much cubic where a cubic meter would be a volumetric sort of calculation. How much weight of gold would be in 1 cubic centimeter of gold, or 1 atomic mass unit of gold would be 79 atomic number and 197 atomic weight. That's about 197 atomic mass unit. Silver is also another one you should remember. So 47, 107, 108, 109, but I don't know what to tell you any shortcut way to remember that one, but that's that. So that's the introduction to the Amz5x12 matrix in its chemical configuration. Remember now, this is not the periodic table, but a relative of the periodic table. The periodic table is designed and arranged in groups and columns, and the groups and the column maintain certain properties. And you have specialized alkaline group. Like magnesium would be in the alkaline group. Sodium would be the alkaline group here with the reactive elements. Sodium, potassium would be in that same group. Sodium, potassium, very, very reactive elements there. And all of those would have also valence 1. So the groups have property with the same valence as well. And rows, and then we have lanthanide series, and you have the actinide series, you have the halogen group, you have the alkaline group, you have the metalloids, metals and non-metals. All of that is arranged, especially arranged in the periodic table. So like I said, the Amz5x12 is a relative of the periodic table. And we're going to show that these application does involve the stem, the steam, and the stream.